All right, ladies and gents, we're back at it again, trying to find the area of composite figures this time. So get out your notes and let's get started. So first things first, what is a composite figure? It's going to be a figure that can be separated into regions that are basic plane figures. So in other words, it can be broken into triangles, parallelograms, trapezoids, rectangles, circles, etc. If we ever want to find the area of a composite figure, we're going to divide the shape up into the regions and find each area, then find the sum of the areas. So like, for example, in number 1, we have a shape here that you can see can be broken up into a rectangle and into a trapezoid. So if I want to find the area of that whole shape, first I'm going to find the area of my rectangle. And I know it's base times height, where the base is going to be 23, and your height is going to be 12. And therefore, your area of that rectangle is going to be 276. Then you need to jump over and find the area of your trapezoid. So here, the trapezoid's formula is 1/2 height times the quantity of your bases added together. And your height here, we have to do a little bit of work for. So you can see that you have this lovely piece right here that is completely and totally 18. And then you have this little piece over here that's 12. So if I want to find the height of my trapezoid, I just got to take that 18 and subtract the 12 to find that I have 6 left over. So that's their height. And then your bases are going to be 23 and 15. So then when you plug and chug that all into your calculator, you'll find that the area of that trapezoid is going to be 114. So the area of the total figure is going to be those two things added together, which is going to be 390 square centimeters. All right, let's do it again. This time, spice it up just a little. So if you look at number 3, hopefully you can see that it's 3 different figures in one. So we now have a triangle, we have a rectangle, and we have a semicircle. So we need to find the different dimensions for each of those. I can tell that this piece right here that I just highlighted in blue, that's going to be a 9 because the other side of the rectangle is a 9. And then if that's 9, then that means that this piece over here is also 9 because they're both radius or radii of that semicircle. And then I can also do a little bit of work to figure some other stuff out. So like, for example, this piece right here also has to be 9 because, again, if I drew another radius there, that would be 9 because the circle's radius doesn't change. So that means that this piece right here, that is going to be 26, the big, long total piece, minus 9, which means that that will be 17. That piece is 17. Okay, and so what does that mean that this piece of the triangle would be? Well, if the big piece is 17 and you already have, if this piece right here is 17 and you have 7 of it over there, that means you have 10 left over within that little spot right there. So now I think we probably have most of our dimensions that we can jump right in and start finding the area of each of them separately. So let's start off with the triangle. Area formula is 1/2 base times height. And in our triangle, our base is going to be 9. And our height we already found was 10. So the area of the triangle, or figure 1, is going to be 45. Now let's jump over and find the area of our rectangle. Your base here is going to be 9, and your height of your rectangle is going to be 17. So the area there is going to be 153. And then finally, let's find the area of our semicircle. 1/2 pi r squared. Remember that a whole circle is pi r squared, so a semicircle is just going to be half of that. And therefore, I'm going to plug in just the radius. Which is 9. So that would end up being approximately 127.23. So if I want to find the area of the whole entire shape, all I have to do is add all those little shapes together. So we have 145 plus 153 plus 127.23, which is going to give us 325 and 23 square feet, 0.23 square feet. Okay? And so that's that one. Now, there's one other type of question that we need to go over today before you leave, and that's, if you flip it over to the back, is the shaded regions. So to find the area of a shaded region, first you're going to find the area of the entire figure. And then what you're going to do is subtract the area of the non-shaded region. Because it's like you're taking that area away from the whole thing. So like, for example, if you look at number 6, first thing I'm going to do is find the area of the whole thing. So the biggest shape in there is the square. So I'm going to find the area of that square, which is going to be s squared. And I just plug in 25 for s. And 25 squared is 625. And then I need to find the area of that circle to take that piece away. So I know when I try to find the area of the circle, I need to do pi r squared, but I don't know what my radius is quite yet, but I can easily find that. So if the square has a side of 25, my radius is just going to be half of that, which will be 12.5. So the area of that circle is going to be approximately 490.87. So if I want to find the area of the total shape, all I want to do, or the shaded region I should say, is take the total and subtract the piece that I took away. So the area of that total shape is going to be 134.13 square feet. All right, ladies and gents, so here are the numbers that I would like you to try when you come in tomorrow. I would like you to do number 4, number 5, and I would also like you to do number 8. A little trick for number 8, I want you to assume that this is a right angle. All right, see you tomorrow.